Hello, I'm coming back for our topic about combustion, incomplete and complete combustion. Okay, so this is going to be our example or examples. We have CH4 plus 2 moles of oxygen gas is equal to carbon dioxide plus 2 moles of water. This is complete combustion. And now we go to the incomplete combustion. This is just only a continuation in my first part because I was interrupted a while ago. So I have already written the examples. Okay, now limited oxygen gas limited. So your product will be carbon monoxide, carbon dioxide plus water vapor. How can you balance this one? Okay, hydrogen 4. You have to put 2 here. Okay, oxygen 2, 4, 5. Here, nothing. Okay, so 2, 2, 4, 5. Here only 2. So here is deficient of oxygen, right? Deficient of oxygen. So a matter of 2, 4, 1, 5. A matter of this is 2, 2 plus 3, a matter of 3. Okay, another one is 5 oxygen here, and on here 2. So a deficit of 3, 2 plus 3 is equals to 5. So can we make this as, we can put this 3 directly here, things like that. 6, okay, then 2, 2, 2. Okay, then you have to put 2 here, right? Things like that. So 2, 2, 2, 6. And how about the hydrogen? Hydrogen is 4. Hydrogen is 4. How about our carbon? It's no longer balanced because this is 2 moles and carbon. Okay, you get the point. Things like that is no longer balanced. So we need to use not the trial and error method. We need to use the algebraic expression way of balancing the equation. Okay? But if you are really good to balance by trial and error method, so there's no issue. I'm just trying to emphasize the most accurate way of balancing the equation by not using the trial and error method. Okay? Okay. First try or first attempt. Okay, it's gonna be like that, right? Okay. Balance carbon, there are 2 carbon there. So here, carbon, carbon, only 1 carbon is gonna be 2. Balance hydrogen 8. Right? So hydrogen here 8, hydrogen here 2. So 8 is equals to, let X as the number of moles of this hydrogen, let's say X. Okay, so 2 times X, X is equals to divided by 4, and X is equals to 4. Put 4 here. Okay, now balance your hydrogen, 4 times 2, 8. 8. How about oxygen? 2, here, 1, 2 plus 4. So 2, 3 plus 4, 7, right? 3 plus 4, 7. Right? So how can you do that? So let X as the number of, moles of oxygen gas there. So X, 2X is equals to 1 plus 2 plus 4. 2X is equals to 7. X is equals to 7 halves. Okay. Fraction. 7 over 2. Okay. 14 divided by 2. 7 here. 3, 7. Carbon 3, carbon 3. No, carbon 2. Okay. Hydrogen 8, hydrogen 8. So, in this way, we avoid improper fraction or any fraction in our chemical reaction is not allowed. This is only whole number, a numerical figure. So we need to multiply this by 2 so that we can cancel out the denominator 2. Okay, so 2 times 2, 4 carbon, H4, 7 halves times 2 is 7, oxygen gas, 2 times CO, 2 CO, 2 times CO2, 2 CO2, 2 times 4, 8 H2O. Right? Like that. Okay. Now, is this balanced or not? This one, try. Carbon, 4. Carbon, 4, right? Hydrogen, 4 times 4, 16. Hydrogen is 16. How about the oxygen? 4. 2 plus 4, 6 plus 8, 14. So balance. So this is your chemical reaction now for your incomplete combustion with limited oxygen. This one. Okay? Things like that. You get the point. Okay, this will be our balanced chemical reaction for our incomplete combustion for our limited in terms of methane. Now, our last reaction will be very limited oxygen gas. So the reaction also will change. Okay, CH4 methane plus very limited oxygen gas. Meaning very less as if there's no oxygen gas added. So what will be our product here? Okay, so take note, there will be carbon always if very limited oxygen gas will be added. So carbon solid plus, okay, here water, CO2 plus water. Things like that. Get the point? Okay. So how can you balance that one? Okay. Because you cannot alter the CO2, it's always be there in your balancing of the chemical reaction. So let's transfer that here. I will erase that here. I will rewrite that in the top. Okay. So CH4 with a very limited oxygen gas, okay, is equals to carbon solid plus CO2 plus H2O. Okay, the carbon monoxide will be released because the methane has a less carbon, only one. If you add carbon monoxide, so it will be too much in your incomplete combustion. Okay, that's why we don't put CO. Okay, this is in the case of methane only, but for others, let's say propane, butane, pentane, you can add also carbon dioxide here. Okay? Very limited VL, so balance the chemical reaction. Okay? Things like that. Okay. Carbon, 2, then have to put 2 here. Hydrogen 8, so we have to put 4 here, no? Oxygen, we have 2 here, 2 times 1, 2 is equal to 2 times 1, 2 plus 4. Then we have 2 is equal to 6, deficient of 4, right? So we need to put X, let the X as a number of atoms, things like that, no? Okay, so we have X, so 2X is equal to chararat, okay? 6, X is equal to 6 divided by 2, like that. Cancel, so 3. X is equal to 3, divided X is equal to 3. Okay, 6 oxygen gas. 4 plus 2, 6, right? Is this balanced already? 2 moles of carbon or 2 atoms of carbon because the subscript is only 1. Okay, and then 2 carbon also, 2 atoms, balance. 2, how about oxygen? 6 oxygen, 4 times 1, 4 plus 2, 6. Hydrogen, 2 times 4, 8, 2 times 4. Balance. This is our balance incomplete combustion with a very limited oxygen gas. Okay? Take note that it would really matter of your oxygen gas if it is too much oxygen gas or sufficient, limited, and very limited. So it could have been stated otherwise complete combustion, right? So only for the FYI, because some, tests and exams in the future, they will trick you out, put adjective here, description of methane plus limited oxygen gas, and then you are usually accustomed to or encountered to usually like carbon dioxide and water only in combustion. So there must be another option to do that. Okay? Things like that. Because incomplete combustion can occur also most of the time, especially if there are leakages, if your internal combustion engine isn't working properly, so it's not really efficient like that. Okay, we can really expect also for an incomplete combustion, by the way. Okay, so this is for the methane. Okay, like that. Take note, if we increase the number of atoms, let's say we will use, let's say, gasoline. This is complicated. Gasoline is a very complicated example. So C8H18, octane family is the gasoline. This is your fuel plus oxygen gas. Let's say we go directly to the very limited. Okay, oxygen gas. Very limited. Okay, so your product will be, take note. Okay, carbon monoxide. Okay, carbon dioxide plus water plus carbon solid. Take note. Okay, now if it is limited only, C8H18 plus oxygen gas limited, then it will be CO plus CO2 only plus H2O. Okay, then complete CaH18 plus oxygen gas, CO2 plus H2O. Take note the difference. Okay, you get the point. So CO2 is and water is the common, right? So you need only to adjust the carbon monoxide thing and the carbon solid. We pattern the carbon solid in our methane. So there's always carbon solid. And then we put carbon monoxide because the atoms of carbon of octane is too many. In case of methane kasi, one atom lang siya. Okay, now, can we balance this? Let's try. Okay, it looks like difficult. This is the first time I balance this one. I'll never try this in my college days. And, I did not practice. This is on the spot. Okay, so how can we do this? Okay. So 8 carbon, 1, 2, 3. There's a deficit of 5 atoms of carbon in the right because 8 here. So we will say carbon monoxide, carbon dioxide, carbon. Okay. So you need to let X preferably in an element. There's no compound because it's easy to solve the value of X in our algebraic expression. So 8 times 1 for carbon atom balance. Okay? 8 times 1, 8 equal. Okay. 1 times carbon, 1 to 1 plus 1 times 1, 1. Then we let X as the number of atoms of carbon solid here because we don't know. So X times 1 or simply X. Okay. 8 is equals to 2 plus X. It's gonna be like X is equals to 6 transposed, right? Okay, 6. So you have to put your 6 here in the carbon solid. So carbon 8. 1, 2, 2 plus 6, 8 na siya. Now, go to hydrogen. Okay, hydrogen. Balance the hydrogen atoms. H. 18. 18 is equal to hydrogen is only here, right? There's no other hydrogen. So let X as the number of atoms of hydrogen. So X. So 2 times X. So 2X. Therefore, okay, X is equals to 9. 9 over. So 8 divided to 9. Put here 9. Okay. Hydrogen, 9 times to 18, 18. Oxygen na itong problema. Okay? Oxygen. Okay. Oxygen. 9, 11, 12. So we need to do the algebraic expression. So here 2. So we need to multiply that to something so that it equal to 12. 2 times x is equals to 12. Okay? 2 times x. Or you can put any number so that it will be equal to 12. This is the same. Okay? 1, 3, 12. Okay, x is equals to 6. So 6 here. Perfect. As I told you, our gasoline in a very limited oxygen gas will produce, okay, 1 mole of carbon monoxide plus 1 mole of carbon dioxide plus 9 moles of water plus 6 moles of carbon solid. Carbon is always solid in an incomplete combustion, with a very limited supply of oxygen gas. Now limited only. Okay, so let's just try to balance it if it is okay to balance also. Okay, so 8, oh my gosh, chart. Right, okay, like that. Okay, so thank you so much. Let's do another vlog for this, for our limited supply of oxygen gas, because it's already lengthy. Bye bye, God bless everybody. I hope you like it, and then you can share this to anybody else for this very special topic of incomplete combustion and combustion. So bye bye, see you later. God bless.